Hello everyone. In this video, we are going to understand what is mesh analysis, how to perform mesh analysis, why we use mesh analysis. Answer to all above questions are: first, we need to understand the basic requirement of any electrical circuit, how to analyze that circuit. For that, our main aim is to obtain power delivered or the power absorbed by different electrical element. Now, as we know that the power in electrical engineering is basically measured with the formula P is equal to V into I. That is, the power absorbed or the power delivered is the product of these two quantity. One is called as the voltage and the second one is called as the current. Okay. So, by using the mesh analysis, we will obtain this unknown current I in any electrical network. That's why we are using the mesh analysis in electrical network. So now let's begin our discussion about the mesh analysis. When we study the mesh analysis, the first point is that what is mean by the mesh. Okay, so mesh is nothing but the loop. It is nothing but the loop or closed path which consists of different electrical element. We know that we have three types of different element. One is the R resistance, second is the L which is the inductor, and third one is the C which is the capacitor. And this circuit is also consist of the voltage source and the current source. So if I want to just define the mesh is nothing but the loop or the closed path in an electrical network. Okay. Now the second point here we have to discuss is that what is mean by mesh analysis. Okay, so mesh analysis is basically the applications of Kirchhoff's voltage law. Okay, that is called as KVL, and which is used to determine the current in the circuit. As I have discussed when I have told you about the power, our aim is to find out the current by using the mesh analysis. So this is the basic function of the mesh analysis. Now what is the KVL? We have understood that KVL is nothing but the algebraic sum of EMF of the circuit is equal to the algebraic sum of the product of current and resistance of that circuit. So by using this formula, we will analyze the mesh analysis. Now, when we have to apply the mesh analysis, there are certain procedure. And what is this procedure? The procedure is that in the first step, we will identify how many meshes are in the circuit. Okay, means ultimately we will find how many loops or how many closed paths are there. Now in the second step, what we will perform? In the second step, we will assign the mesh current to each loop with the direction. Okay, I preferably use the this direction. This is called as the clockwise direction. We can use the anti-clockwise direction also, but as this is the best clockwise best direction to understand the mesh analysis. Okay, now the third step here is that we have to develop the KVL equation to each mesh or loop. Okay, so if we have a three mesh, so we will write the three mesh equation, and in the last step we will solve all this KVL equation so that we will get the mesh current. So this is our aim, to understand the mesh analysis, that we can easily find out the unknown current in the electric circuit. Now we will consider one example here. Okay, so in this I have considered the example where I have the this type of circuit where I have resistance here. There are two resistances here. There are inductor here L1, and this is the inductor L3, and we have the capacitor also C1 and C2. Apart from this, we have this four voltage sources: VA, VB, VC, and VD. Okay, so if this type of circuit is given here, our aim is to identify the first step. What is the first step? The number of mesh in the circuit. Okay, number of mesh in the circuit. Okay, so how many mesh are there, that we can find out. As I have told you that the mesh is nothing but the closed path. So if you see this diagram, so this will be your mesh 1, because if the circuit will start from this positive terminal of the battery, it will goes to R1, then L1 and C1, and it will be closed. So the path which is originate and terminate at the same point is called as the loop, and loop is nothing but the mesh. So I will give this is my first mesh or first loop. Similarly, this will be also another closed path, you can see that. So I will give this as the number 2. So this will be my second loop. Similarly, you can see here also this is again one of the loop, and this will be the third. Or we can say that in this network we have total 3 number of mesh. Okay, so it is very easy to find out how many mesh or loop are in the circuit. Now according to the procedure, what is our second step? Second step is that assign the current to each mesh, so with the direction. Okay, so for the first mesh I will assign the current as I1 in the clockwise direction. Similarly to the mesh 2, I will assign the current in the same direction, which is a clockwise, that is I2, and the third mesh I will assign the current direction to the I3. Okay, so in the second step what we have done, we have assigned all the current to each mesh. Okay, so in that way the first two steps are done. So first we have done the identify number of mesh, and in the second step we have to understood uh, the direction of the currents, where I have taken the clockwise direction. Now according to the procedure, the third step is that apply KVL to each mesh. Okay, and so definitely how many KVL equations will be there? Here we have total 3 KVL equations. Total equations will be 3. Okay, because we have 3 mesh are there and we have 3 unknowns. So when we get this KVL equation in the fourth step, solve these 3 equations, solve 3 equations, and we will get this value of I1, I2 and I3. So in that way the mesh analysis used to determine is used to find out the current flowing in any electrical circuit. Okay, so we have understood the first two steps. Now our aim is to understood this third step, means how to apply the KVL to each mesh. Okay, so for that I have to understood first what is the resistance, what is the inductor, and what is the capacitor, or how to apply KVL to this resistance, inductance and capacitance. So first we will see that. Now first point we will be seeing here is that how to find out the voltage across any resistor. So for that I am considering that the a resistor element having the resistance R in the ohms. For that I will consider one resistor here like this, whose value is R and measured in ohms. Okay, and I assume that current through this is IR, and the voltage across this will be VR. Okay, so VR is the voltage across resistance, IR is the current flowing through this resistance. Then our aim is to find out this VR, that is voltage across resistor. So what is VR actually here? VR is the voltage across resistor. So that can be simply find out by the Ohm's law. We know that by Ohm's law, the voltage is a product of current and resistance. So if I apply to this, so this is VR, this I will become IR, and this will become the resistance value. So this will be the first equation where we get the values of the voltage. Similarly, we can find out the IR. What is IR? IR is the current flowing through the resistor. Okay. So by using the equation 1, I can easily find out IR is equal to the ratio of voltage by resistance. So it's very simple. When we have to find out the voltage across resistor, it's simply find out by this equation where VR is equal to IR into R. So in that way we will find out the voltage across resistor. Right? Now second we will be finding out the voltage across inductor. For that I am considering that a inductor element having the inductance L, and the inductance of the inductor are measured in Henry. So Henry is the unit of inductance. So now first I will consider the inductor. So inductor is nothing but the coil. Okay. So I have considered inductor here. So symbol is L, unit is Henry, so it is represented by H. Okay. Now if I considering that the current flowing through this is IL, okay, and the voltage across this inductor is VL. Okay. So what is our aim? We have to find out the VL. What is VL? VL is the voltage across inductor. Okay. So that can be find out by the formula VL is equal to L multiplied by DIL upon dt. Okay. This is according to Faraday's law. According to Faraday's law. Okay. So the voltage across any inductor is equal to L di by dt. That is the rate of change of current with respect to time. So here you can see that we have one term d by dt. Okay. So we will have to substitute that to get the proper answer. So put d upon dt is equal to p. Okay. Small p or p. I will say this p as a mathematical operator. Mathematical operator. Okay. Fine. So if I replace this in equation 1, so your VL is come out to be L into P, because d by dt is represented by P into IL. So that will be your actual equation of the voltage across inductor. So you can write the voltage across inductor by equation 1, VL is L di by dt, or you can write VL is LP into IL. Now we have studied that according to Ohm's law, that voltage is actually the product of current and resistance. Okay. So I can say that this LP is actually the Z. What is Z? Z is the impedance, and this current is measured in ampere. Okay. So this is I into Z. So this is the volt, that is voltage of inductor, is the product of Z into ampere. So what is the value of Z here? Z is also written as LP, and it's measured in ohms. Okay. So this is the new thing we have find out here. If we want to write the inductor in ohmic value, we will write in ohm, and if we want to write the inductor value in Henry, we simply write L. So L is measured in Henry and LP is measured in ohms. Okay. So remember this point. Right. Now about the voltage across capacitor. So for that I am considering a capacitor element having capacitance value C, and which is measured in farad. Okay. So now I will draw the symbol of the capacitor. We know that the capacitor is basically two parallel plate out of which one is a positive and another is negative. So symbol is C and measuring farad. Okay, so I will assume that the current flowing through this is IC, that is current flowing through capacitor, and VC is the voltage across capacitor. So what is VC? So our aim is to find out VC is the voltage across capacitor. Okay, now we have to find out the values of VC. So how we get the values of VC? We have studied one formula that Q is equal to C into V. Okay. Now if I differentiate this equation, dQ upon dt is equal to C is a constant, that's why C dV upon dt. And dQ by dt means rate of change of charges, and rate of change of charges is called as current. So I is equal to C into dV upon dt. So from this equation we can easily write down as V is equal to 1 upon C, because we have to integrate this value, so then only we will get the V integral I dt. So we can write this is VC, that is the voltage across capacitor, and this value I will be IC, and this first equation will gives you the values of VC. So we have derived the voltage across capacitor equation from the values equation of the current. Now we can see here integral dt. So we have studied that P is equal to d by d upon dt, and we can replace here in other terms also the value of this P term in the integral form as integral d by dt is equal to 1 upon P. Okay, so if P is equal to d by dt, then if we differentiate, that will become 1 by P here. Okay, integrate this equation and we will get integral dt is equal to 1 upon P. Substitute that value in equation 1. So if we substitute that value in equation 1, your VC is come out to be 1 upon Cp into IC. Okay, we have substituted integral dt as P 1 upon P, so this will become here. So this will be equation number 2. So this will be the values of the voltage across the capacitor. Here we can see that the value of the voltage across the capacitor is 1 upon Cp into IC. Okay, so this Cp is measured in ohms. Okay, so it will be the impedance of this capacitive circuit, and C is measured in farad. Okay, C is measured in farad. So in that way we have find out in a table what we have studied up till now. The first I will consider the element. The second part I will consider the impedance, and impedance is measured in ohms. Okay, and I will take another term which is the admittance. Okay, admittance is nothing but the reciprocal of impedance, that is admittance is represented by symbol Y and it is the reciprocal of impedance, so 1 upon Z. Okay, so what will be the answer of impedance? It will be reverse that of the admittance. Okay, so what we have studied the first element we have studied the resistance. Okay, which is represented by symbol R and it is measured in ohms. So its impedance value is, we have studied, R. Okay, and reciprocal of R is 1 upon R. Okay, and its unit is mho. Okay, the second we have studied the inductance or inductor. whose symbol is L and measured in Henry. Fine. Then its impedance value we have find out that LP and measured in ohms, whereas its admittance value will be 1 upon LP and measured in mho. Okay. The third and last one, we have studied the capacitance. Okay. So capacitance is measured in C and value is in C and measured in farad. So its impedance value is 1 upon Cp that we have derived already and measured in ohms. So its ohmic value, its impedance value will be, sorry, its admittance value will be Cp and mho. Okay. So when we use the mesh analysis, we will use these values, the impedance value, because it depend upon the Kirchhoff's voltage law. So according to Kirchhoff's voltage law, it is the algebraic sum of E is equal to algebraic sum of IR, where R represent the ohmic value. So we have the ohmic value of resistance is R, ohmic value of inductance is LP, and ohmic value of the capacitance is 1 upon Cp. Okay. So here I have discussed the some basic concept of mesh analysis, why we have to understood the mesh analysis, what is the purpose of understanding the mesh analysis. Okay. So